Question 2b. A woman can row a boat at 4 meters per second in still water. She rows a boat across a 80-meter wide river. The river flows at constant speed 3.5 meters per second parallel to straight banks. She wishes to land between A, B and C. So she wants to land in between B and C. The point B is directly across from the starting point, and the point C is 20 root 3 downstream from B. Okay. If theta is the direction she takes, find the range of values of theta if she lands between B and C. So we're going to have like an inequality answer at the very end. Okay, let's start off with what we're going to use. We're going to use velocity of the woman. Okay, velocity of the woman in water. Oh wait, can't use that. Velocity of the woman in the river. And the velocity of the river. Now please remember, there's a trick here, right? Here is the trick, right? The velocity of the woman. So imagine, for example, you're paddling and you can paddle at 4 meters per second in still water. That's actually the velocity of the woman in the river. Imagine the river's going 2 meters per second. Okay, and that's the velocity of the river. Therefore, the velocity of the woman to an impartial observer on the bank, they would see the woman traveling at 6 ms minus 1. Essentially what we're looking at here is the velocity of the woman equals phi WR plus phi R. Is that okay? That's the equation we're looking at. Okay? Remember, it's not the velocity of the river and the woman, it's the velocity of the woman in the river. Next thing you're going to talk about after that, guys, is you're going to be doing, let me see, you would start off with this equation here. Phi WR equals phi W minus phi R. Then you move the phi R over to the left, you get the equation I was just talking about a minute ago. Okay. Next, we're going to have to collect some information about our first one. Okay, so we're going to do some Magder. Okay, anybody remember what Magder is about? It's magnitude and direction. What we're looking for is roughly 3 pieces of information on our. Okay, so we have magnitude and we have direction. Now, we know the velocity of the woman. We don't know her magnitude, but we know she has to go directly north. She's got to start here, and although she's aiming this way, the river's going to keep her going straight across, so she goes directly north. We know the velocity of the river's going directly east. We know the river's going at 3.5. We know she attempts to go at 4. That's not actually what happens. Now we got to construct our triangle. Please remember, it's a bit like the A equals B plus C gig. Vector A must equal vector B plus vector C. Okay, so let's start off with the velocity of phi woman on its own. Phi woman goes straight up, straight north. Velocity of the woman. Okay. Next thing, so velocity of the woman's going straight across. Velocity of the woman has to equal the other two added together. So we'll start off with phi WR, which has to go this direction here, and then it gets counteracted by phi R. So phi R goes right, and phi WR goes up. So essentially, if you're the blue dot, that's your start, that's your end. You can either go straight up this way, or you can take 2 roads to get to the same path. That's the triangle law of vectors. Okay, now we're going to have to fill out some information for ourselves. Well, what we know about phi R, we know that phi R equals, 3.5. Okay, we know phi WR equals 4. Now we can get angle X. In turn, we can also get angle theta, because theta is downstream. Or you can get theta directly if you want. You can use alternate angles, and we can find theta directly this way. So we actually have theta straight away now. We can say that sine theta or sorry, cos theta, excuse me. Cos theta is your 3.5, which is your adjacent, divided by her hypotenuse, which is 4. We're going to cos inverse that 3.5. Cos inverse that 3.5 over 4. What we get is 28.955. 28.955. Okay, so theta equals 28.995. Okay. Now, situations like this, guys, always good to check your marking scheme. 28.955. We're in business, okay? So that would have got us in the leavings here, that would have got us 10 marks. Now we're on to part 2, which is also worth 10 marks. And part 2 is the trickier part, but once again, shouldn't be any too much concern to us, okay? So here's what we're going to do next. So we're going to rub all this out. We don't need any of this, but we do want the 28.995. That will be one of your values, okay? Now, if you want to go further downstream, see the way we aimed in this direction here. If you want to go further downstream, just don't aim as far to the left. Aim sort of upwards, and you'll get dragged further downstream, okay? Now, what we need to do is we need to figure out what angles are we dealing with here again. Now, once again, we don't know the direction of the woman just yet. We still know the river's going east to 4.3, and we still know that the woman is going at a magnitude of 4 in the canoe. What we don't know is we're trying to work out our other angles. Okay, so here's what happens. The first thing I can find out is I can find out this angle here, how far we're going to get dragged downstream. Well, this is an angle of 20 root 3 as my adjacent and 80 as my opposite. So I should be able to calculate an angle x here. Okay, so let's find out. So tan inverse opposite over adjacent, which is going to be 80 divided by 20 root 3. We got there is 66.59 degrees. So 66.59 degrees. X equals 66.59 degrees. Now, you could also do it this way. You could also do Pythagoras' theorem. If you don't want to round off anything, you have 20 root 3 and x. Just find the hypotenuse. Hypotenuse is going to be 80 squared plus 20 root 3 squared. Square root the answer, 20 root 19. Okay, now you can find out where your cos x and sin x are very easily if you need to use them later on, which I think you will. So cos x will be, what's it, 20 root 3 divided by 20 root 19, which is an unusual one, but still, which is root 57 over 19. And finally, the last one is the sine, which is going to be 80 divided by opposite over hypotenuse, so 20 root 19 here. And we can see here that that is 4 root 19 over 19. Now I might need those values later on, okay? So I'm just going to store these here. Now, what do we know about this? Well, we know that the woman goes east x degrees north. East x degrees north. Now, please remember, x isn't a variable. We actually know what x is. X is 66.59. But we also know the exact value of cos x and sin x if we were to need it. Okay, that's the other thing we also know. Okay, now, we know the direction velocity of the woman goes in. The velocity of the woman goes this direction here at an angle x. No bother. Now, what we also know is that we're going off at an angle theta here as well. So theta is in this direction here. We have no idea what angle theta is. Perhaps we don't even need it. Okay, and here we go. So this is a philosophy of the woman. Remember, if you aren't getting this, she starts at A and she ends up at C. That's starting at A, ending up at C. The velocity of the river is this part here, which is your 3.5. No bother. And you have this to be 4. Remember, it's not a right angle triangle. It might look like a right angle triangle, but it's not. Next thing I know is that using alternate angles, I can say that this is angle X. If I can find out angle X, I should be able to find out angle Y. See angle Y here? Should be able to figure that out. So here's what we're going to do. We're going to use the sine rule. We're going to use 4 divided by sine X equals 3.5 divided by sine Y. And what I'm going to get here, guys, is I'm going to get sine Y, bottom right, top left. So sine Y on its own. I'm going to get 3.5 sine X. And I'm going to divide that by 4. Lucky enough, I know the exact value of sine X. So it's going to be 3.5, 3.5, 4, multiply by 4 root 19. Then I'm going to divide all this by 19. So it's 14 root 19 over 19. Going to sine inverse this to find out what the Y value is. Sine inverse, my answer. Whoa. Okie dokie. And pause. I forgot to divide by the 4. See the 4 here? I also have to divide by that 4. So it's 7 root 19 over 38. Okay. So let's try this again. 7 root 19 over 38 when you put all that into the calculator. Now we're going to sine inverse this number, shift sine inverse this number, and we get 53.413 degrees. Now, I'm just out of interest, I'm going to use that decimal from earlier, 66.59, and for this here and see if it would have made any difference. 66.59, all right, let's try it out. 3.5 sine 66.59, all divided by 4, and then shift sine inverse answer 53.415. So you can see there's very little difference there. This is the more accurate answer though. Okay, so this one, so to find out the angle theta, it's going to be 180 degrees. Take away our 53.413, and then finally take away our 66.59. See what we get in the calculator here. 180, take away 53.413, take away 66.59, and we get 59.997. Okay, so that's the bigger angle I would have went up at. See, we went up at a steeper angle, less than 59.997. Interesting to see what the marking scheme would have got there, so let's find out. They rounded off to 60. Fair enough. I reckon my answer is pretty accurate though. Okay, so you can round that to 60 if you really want, but I think I'm pretty accurate by keeping that as a third. Okay, no bothers, and we're done.